Let's speak about Cisco sandboxing. Or about sandboxing in general. I think also somebody asked about, can you speak about sandboxing in a couple of let's do a basic talk of Cisco sandboxing or sandboxing in general. So the problem with why do we have sandboxing now, because signature based malware detection based on signatures, it's obsolete for a long time. Because as I was saying, we had so many new malware samples per day that it's humanly impossible to keep track with that and fire signatures and push those signatures in appropriate time to customers to keep customers protected. So you need to do something else. So then we have this capability which is called sandboxing. Of course, not only Cisco does it, all vendors do it. Vendors that have next-generation firewalls. There are also vendors that they do only sandboxing in the network. Better performance. I just said Cisco sandboxing because we keep speaking about Cisco products. So the problem is we have what they name polymorphic malware. That is the main trigger that signature-based malware detection is very less effective nowadays. So for this kind of attack, sandboxing technology is very useful. So polymorphic means not only we have a lot of new malware, but we have malware that changes. They change very few things in a malware version, which is gonna basically the signature is not gonna be able to detect that malware. So that's what polymorphic means. So an attacker could take a malware for which a company, let's say a vendor or all vendors have deployed signatures, can take a malware and within minutes provide tens of variations of that malware, which is not going to be detected by signatures. Also, with the old versions of signatures, it was very bad because things not being done automatically in cloud. It took a long time for the antivirus vendors to release the signature. It could be a couple of hours, couple of days. Then till the signature is published. Then till the customer downloads the new signatures. Then till the customer pushes those signatures back to its PCs, its clients. So the chain was too long. It took too long for a signature to actually be activated on a user's device, and by that time maybe it was too late to begin with. And of course it was even with that approach, it was no longer secured, because as I said before, an attacker takes a malware and within minutes it provides tens of variations of the malware, which is not detected by signatures. So that process was completely useless. So we had to come with something smarter, better, and that they call the sandboxing. Again, the name of the technology says exactly what it's doing. So what sandboxing does is going to take the attachment of course of a session, is going to detonate those files which are unknown. Why do I mean unknown? Because of course before we do this process, which is CPU intensive, we're gonna do a hash of the file and compare that hash with known hashes for known malwares. So the first process is going to be doing that. The user transfers the file back and forward. Let me show you how it works. So if you look at the diagram back again in here. So this is the user session to the ASA file with Firewall services going out to the internet. And of course, when we download something, whatever that is, and traffic returns. And traffic returns is inspected by the Firewall services module. And what happens to begin with, the sandboxing capability, the AMP, is going to create a signature of the file and query the cloud or the on-premises version of the cloud, if that's what you have. Query the cloud saying, is this SHA signature known to be malware? Yes or no? And the cloud is going to say yes or no. It's going to be a basic answer, yes or no. Because we want to avoid, so clearly as the cloud identifies new malware, it provides signature on those malware, but not like it's not going to fire up a signature to identify the malware. It's going to create a hash of the specific file which contains the malware, so that if that file is being seen again in the internet, the next-generation firewall is going to create a hash of the file, compare with the hash stored in the cloud, and see if it matches. Then it means that it is the same file as seen before, which it was malware. We take this approach because it's clearly way better than to make the ASA firewall or the cloud to process switch, do sandboxing each time over and over for the same file if it is known to be malware. It doesn't make sense. So the first step is that we try to compare the signature of the file. We query the cloud to see, hey, do you know if this file is known malware or not, based on the created signature. And if it is malware, then clearly we're gonna drop the session. If it's not malware, then we're gonna go and do proper sandboxing, which means we're gonna detonate that unknown file. So we're not sure if it's malware or not in a safe environment, and then we're gonna record its actions. So basically, what happens? What is the beauty of the sandboxing is that two polymorphic copies of the same threat are going to yield virtually identical reports. So not only we are able to see if to detect unknown malware, but also once we have detected a specific malware code, then a variation of that would most likewise in a lot of cases create the same signature, which means we're going to be able to detect, once we have detected a specific malware code, then we're going to be able to easily detect also variations of that malware. But of course, that's easy, so we're going to detect no malware, fire up a signature for that. Based on that, we're going to be able to quickly detect variations of the same malware without having to involve a lot of process switching to actually do sandboxing. But then if the file being inspected doesn't match any signatures, so it is not seen before as being malware, we have to actually do sandboxing and properly analyze the payload to see if that's new malware or not. And what happens when we do sandboxing? Of course, a lot of vendors do different things. Basically, we simulate, we simulate that piece of code on different environments, on different versions of systems, and see what happened. We try to simulate what would happen if that piece of code would reach the endpoint in the end. So we examine the results basically of detonating that piece of malware, and a lot of attributes are being examined back and forth. We're going to look at anti-debugging techniques or keystroke logging to see if that's going to be a clear let's say identification that is malware. Or we have, if we detect suspicious activity, like for example, when the code is detonated when the user, when we simulate that, is going to access specific registry keys, specific system files, or is going to dynamically link different sets of libraries from the operating system. So we try to again simulate what would happen if that file would reach the endpoint, and look at suspicious activities to various attributes. Also, what AMP does is going to examine also, of course, the main name system and HTTP traffic for botnet characteristics, because clearly when we detonate the code in the cloud, then we're gonna see, okay, if the code was, if the malware, if that file has reached the endpoint, then is it gonna perform specific DNS queries to specific known command and control centers? Is it gonna initiate any kind of weird traffic out on the internet? Because technically speaking, like imagine when you download a file from the internet, like a PDF or whatever, it shouldn't that file when you download it and you get it on your device, it shouldn't go on the internet and initiate DNS queries or HTTP queries or send emails or whatever. Clearly that's something that is more 100% at that point. So that's also something else that AMP does. Also, of course, sandboxing gathers essential data on Cisco from network activity for botnet command and control connectivity. As I was saying before, and as we're going to speak in more details about this when we speak about sandboxing limitations, because it could happen that we detonate the file on a simulated environment in the cloud, but nothing suspicious happens. So it's like a regular file which stays in there. But maybe, you know, like a month later or 5 hours later, instantly it starts, you know, sending some traffic, weird traffic on the internet, or starts killing some processes on the wizard host, like it's going to start killing the antivirus processes or things like that. Because that's basically what it's known as a silent piece of code, or which is a part of the which is included in the Advanced Persistent Threat Convention. Of course, because as I was saying before, sandboxing has its own limitations. That's why you have to build a security architecture. You cannot, you know, rely your security or on just buying the best firewall out there. It's actually way better to buy a firewall which has a good price, you know, good security, but it provides good integration with other solutions in a network that they together build a security architecture, and in the end you end up protecting the network, you know, in all of those phases of the attack, before, during, and after. That after is very important, because sooner or later you're going to get attacked, you're going to get compromised, and you need to detect the attack as fast as possible, quarantine and remediate. So quarantine automatically and remediate while not also automatically, and ICE allows that. Cisco ICE. So sandboxing limitations, inherent efficacy. So basically, as I was saying, running a file in a sandbox to a lot of, you know, and checking a lot of attributes, it is not a guarantee that the disposition in the end is not going to be a threat to your environment, for a couple of reasons. So first of all, because you know, the code can be programmed to, you know, stay silent for weeks or months. So there's no abnormal behavior on the system once, you know, it is downloaded on system. And second of all, when doing sandboxing, we can, you know, nobody can properly simulate all of the possible, you know, versions of the operating systems, of the browsers, of the vulnerabilities, of the, you know, it provides security up to a point, but not perfect security. Likewise, evasion techniques. So clearly, because once sandboxing became more and more intelligent, and more you know, enterprises have started implementing sandboxing solutions in their networks, also the hackers, the malware authors, have started deploying a number of techniques to bypass sandboxing analysis, because clearly they know how you know, the vendors are doing sandboxing, and clearly they know how to bypass that. That's why they state that, you know, to be able to provide a good security with your solution to your customer, you need in your team of engineers, you actually need people that have been, you know, have gone you know, have been in there, have been doing bad things for a while. They know how things are built. They know you know, how to proactively defend, or, you know, they know how to let's say prevent the next moves of the hackers. So sooner or later it's going to happen that, you know, some malware is going to bypass all of the checks you have in there through evasion techniques. And also the most important one is that sandboxing, it is at point in time detection only in general, in most cases, because we take the payload, we simulate it in a lot of environments, and then we come up with an answer: is it malware or no malware? And that's it, you know, and then we forget about it. And that's where Cisco, actually in here, Cisco has to their AMP product something very, very, very smart. They do continuous retrospective analysis. We're gonna get at that point in more detail when we speak about, when we get into the details of AMP in there. So Cisco, that's why through all of those acquisitions, they do AMP not only point in time, but they do it also by constantly, monitoring the behavior of the endpoints and the results of content being downloaded back and forth. In which that means is that's the reason why would you need AMP on the endpoints as well. Because you would ask yourself, why would I need AMP on the endpoint since traffic is AMP inspected, is sandboxed in the cloud or in the network, by the Firewall services module, by the web security appliance, or by the email security appliance. Because all of those in general can provide only point in time. They take a yes or no action on the inspected piece of code. But then if the model is silent for a month or 2 months, or starts building up its let's say it starts to detonate a lot later, then you need presence on the endpoints to detect that abnormal behavior, which is created by a PDF file. Like a PDF file is going to start and kill processes, or start making copies of itself and stuff like that. The only being present on the endpoint, you can detect that.